Okay, as always, like a diagram. So A and B travel in the same direction. A collides with B. We're then told, after the collision, they're travelling like this. This has velocity u, this has velocity 8u over 5. I've written the masses in. The distance from the wall is d. B hits the wall, bounces back, and A obviously carries on. And as it bounces back, it'll hit again. Now we know this velocity here because we know the coefficient of restitution with the wall is a quarter. So it was 8u over 5. It's now going to be a quarter of that, 2u over 5. Okay. So we've got that scenario and we've got that distance. So we need to look at the distances B travels. So B travels a distance of d at a velocity of 8u over 5, and also a distance of x at 4u over 5. Oh, sorry. So what's the coefficient of restitution? Half, sorry. This is not 2u, it's 4u, apologies. Think of an old question. Okay, so 8 at 4u over 5. Meanwhile, A travels a distance of d minus x at a velocity of u. Now we know they both travel for the same amount of time, so we can look at the time. So times are equal. So we can say, therefore, we've got distance over speed. So d over 8u over 5 plus x over 4u over 5 must be the same as d minus x over u. Okay, so now it's just a matter of a bit of algebra. Times this top and bottom by 5, so we get 5d over 8u plus 5x over 4u, so I'm going to double it, so I'm going to have 10x over 8u equals, and I might as well multiply this one by 8 as well, 8d minus x over 8u. So now I can just compare the numerators. So 5d plus 10x equals 8d minus 8x. So I end up with 3d equals 18x. So d equals 6x. Find x in terms of d. Okay, so x equals d over 6. Alright, now given also the coefficient of restitution between the particles is a third, show there's no third collision between A and B. Alright, so basically we're interested now in the speeds after this collision here. Okay, and we'll see what happens then. So let's, after that collision, let's draw it again, sorry. So we've got 2m, 3m. This is going at u. This is going at 4u over 5. Mass 2m, mass 3m. That's before, and afterwards we're going to have this scenario. B and A. You don't really know which direction they're going in. I could have picked A bouncing back just as easily. So, conservation of linear momentum. So, taken that way, we get 2mu minus 12mu over 5 equals, I've made both these negatives the way I've drawn it, minus 2mb minus 3ma. So move things around a little bit, we get 2u over 5 equals 2b plus 3a. Make a note of that. We're now doing the impact law. And we've got the speed of separation, which is, we take to the right as being positive in this case. Doesn't matter. B minus A, it's the difference between those ones, equals the difference between these two, which is going to be coefficient of restitution times the combined. So it's u take away a minus. So it's that take away a minus u effectively. So 4u over 5. Okay, because they're going towards each other, we add the two speeds together. And here we get b minus a equals 3u over 5. Equation 2. So now it's just a matter of solving that to find a and b. Let's just move it up a little bit. So we're going to solve those two using 1 and 2. So we've got 2u, in that space here, 2u over 5 equals 2b plus 3a. 6u over 5 equals 2b minus 2a. Okay, just doubling this one. And then we're going to take one away from the other, so the b's cancel, and that implies, leaves us with minus 4u over 5 equals 5a. So we've got a equals minus 4u over 25, okay, which immediately tells us in my original drawing I had a going to the left, whereas in fact, because it's negative, it will be bouncing off. Okay, so so now we know that b equals 3u over 5 plus a. Okay, using the this formula here. So we know what a is now in terms of u. Oops. So we've got 3u over 5 take away 4u over 25. Make them both over 25, so that's 15 take away is 11u over 25. Okay, so we now know that b is travelling away at 11u over 25, and a is in fact gone the other way at 4u over 25. It's then going to bounce off. So after let's write around. I've got a's and b's right way around. Sorry. Okay, so I've just actually realised that I've called a the velocity of, this is actually particle b and particle a, so my labelling wasn't too good, but anyway, so I now know that a is going that way, and b, sorry, velocity a is that way, so it's b is going that way. Very confusing. If I find velocity b, so b equals 3u over 5 plus a, using the formula here, which equals 3u over 5 plus, or minus, sorry, minus 4u over 25. Make them both over 25, so that's 15 over 25, take away 4 over 25, it's 11 u over 25. Okay, so the scenario I've got, either perversely A is moving that way at 11u over 25. Particle B, which I've got a velocity of A, but is going to go this way initially with a velocity of 4u over 25. It's then going to bounce off and come back, because coefficient of restitution is a half, with a velocity of 2u over 25. Okay, so B will never catch up with A. So no third collision. Okay, so hopefully you understand this lettering was poor. It's obviously B should be little b, A should be little a, but perhaps that's a little lesson to myself, a bit more careful in my labelling. But the point is, you're trying to find the velocities of the two and show that velocity B is slower than velocity of A, therefore it's never going to catch up.